Welcome to the section of quantitative ability, and this session we are going to discuss about the quadrilateral. Quadrilateral is one of the important figure in your geometry. It is not going to help only in geometry, it is going to help in your entire quant preparation, because it is one of the important figure which can be interrelated or which can be correlated with so many type of problems. In this session we will focus on the quadrilateral and its properties. Quadrilateral is a general name. Any of the polygon of four-sided we will say quadrilateral. Based on the certain particular or peculiar properties, this quadrilateral will change into trapezium, parallelogram, rectangle, square, rhombus or kite. These 5-6 famous geometrical figures are there which we are using for the CAT exam, or questions will be asked in CAT or MBA entrance test. Once you will look like an entire type of quadrilateral, then you will find so many variants. All variants are not coming because condition is there. Most of the times question will be picked from the symmetrical figure. Then all these quadrilateral, all these geometrical figure what I told, that is based on the symmetry. Then based on the symmetry only most of the time question will be picked in your aptitude test. Then this session we are going to discuss in detail about the quadrilateral and its another three variant or three geometrical figure, that is you can say extension of the quadrilateral, means quadrilateral, trapezium, parallelogram and rectangle. One more session will be there, next session, that will be your quadrilateral and its properties, session 2. In that session we will discuss about the square, rhombus, kite and other miscellaneous figure related to quadrilateral. In this session just will try to focus for next 30 to 40 minutes. You will able to understand or you will able to grasp in better way. But this session is going to one of the milestone for your preparation, because without understanding various properties of quadrilateral or parallelogram or rectangle, you will face lot of problem to solve the geometry question. And be careful, whatever properties I will discuss, you try to understand and try to revise, or try to few things you have to memorize also. Not many things, few things, like few formulas or few properties you must memorize. And another point is there, how to distinguish based on the certain properties between two geometrical figures or between two type of quadrilaterals or among two or three types of figures. This is most important, because which property is going to hold good for parallelogram but it is not hold good for a square. Which of the properties are holding good for a square but it is not holding good for quadrilateral. This distinction is must be differentiated. Then this session we are going to discuss about quadrilateral. First thing, general properties, what is quadrilateral. Afterwards we'll come to the next variant of quadrilateral, that is cyclic quadrilateral, or you can say simple thing, if a circle is circumscribed of any of the quadrilateral, not any special quadrilateral, any of the quadrilateral, then what are the properties you have to discuss and you have to apply. Next is properties of trapezium, next variant of quadrilateral, when one pair of opposite side will be parallel but one pair of opposite side will be non-parallel. Here mainly we will discuss about the isosceles trapezium. Otherwise you will see the variant, then so many type of trapezium will be there. Generally all will not useful for exam point of view. Next will come just a little extension of the trapezium, that is called parallelogram, and this is going to become a most important for your quadrilateral point of view. If parallelogram you have not understood properly, then you will not able to apply property for parallelogram, rectangle, square and rhombus, and you will not able to distinguish the different properties which are going to hold good for parallelogram and rectangle or other figures. Then this you must understand properly and give proper attention for all the properties. Next is your rectangle and its properties, and afterwards we'll see lot of questions, example questions, almost 10 plus questions, and various tricks and techniques we are going to learn. Then just before starting, it is one of our small custom, we'll just look the syllabus, because always you should be in the line of the preparation. Any of the session you are doing or any of the chapter you are doing, you must know where we are and what we are doing. This is your CAT. CAT is divided in 4 sections: QA, DI, LR and VA. Now we are doing the QA further divided in 4 blocks: block 0, block 1, block 2 and block 3. Now we are doing the block 2, that is related to your completely dedicated to your geometry or geometrical structure. Now we are doing the concept folder 1 and session number 4. Just we'll start about quadrilateral. Quadrilateral is a general figure or general polygon of 4-sided. Only thing is it must be closed. If it is not closed, then we can't say it is a quadrilateral. Like if we are making like this, just suppose if we are making like this, it is not a quadrilateral. It must be closed. Closed figure of 4-sided polygon is called quadrilateral. Like due to I made very, you can say no symmetry way, means side is not parallel, side is not equal, everything, all variation you will find in this figure ABCD. What are the properties must be hold for quadrilateral? One thing is very sure, we know about previous session and basic fundamental of the geometry. Sum of the all interior angle will be equal to 180 into 2 for any of the 4-sided figure. Any of the 4-sided figure, it will be always 360 degree. 180 degree for triangle and 360 degree for your quadrilateral. Next, if we are going any of the variant, either trapezium, parallelogram, anything, it will be always equal to 360. That is that is fixed. Or sum of exterior angle will be always equal to 360. That is also 360. But exterior angle is fixed. Interior angle will vary based on the number of sides. I think we know, no need to emphasize much. How to find the area of any of the quadrilateral, general quadrilateral? Only one thing you have to do, just to pick any of the diameter of the quadrilateral, anyone, whatever you want or whatever you looks good, and you put 2 perpendicular from the opposite vertex. Like here we have picked AC as a diameter, we picked 2 vertex D and B, and we have dropped the perpendiculars like BF and DE. Afterwards it will become very simple. Just you can correlate like a kind of, it will be divided in 2 triangle and we know the area of the triangle. Based on that we will make the area of the quadrilateral will be equal to half into AC into DE plus BF. Now another properties that is very much interesting, or many of the times it will be checked through variety of the problems, variety of the situations. OA square plus OC square will be equal to OB square plus OD square. What is O? O is the point of intersection of your diameter. Whatever diameter will cross at some point, because it is internal diameter, it cannot go outside of the figure. This is point of intersection of diameter. Then this point of intersection, if you are taking OA square means this side and OC square this side, OD square and OB square, then it will be always hold good. Any of the quadrilateral means we can say this property is going to hold good for any of the figure which is 4-sided. Means it is going to hold good for parallelogram also, trapezium also, rectangle also, or square also. In place of O, if you are changing the point, then how it will change, that also will look. AB equal to C into D. This is just area of this part and this part. Means product of opposite area, whatever made by the 2 diagonal, it will be always equal. Means product of A into B must be equal to product of C into D. Okay. Now area we can find in some different way also, like half into D1 into D2 sin theta 1, like this angle you can pick, or D1 D2 sin theta 2. Anyway it is going to become same only. Why? Because theta 1 plus theta 2 will be equal to 180, and we know sin theta equal to sin pi minus theta, then it is not going to make any change. Then these 3-4 are common properties. Just we'll look through LTI. What are the different kind of figure or different kind of geometrical figure will be generated from quadrilateral family? One itself quadrilateral. Next is your trapezoid, that is your common figure. Means once you are making something different from quadrilateral, then it will become trapezoid. Trapezoid, one of the special figure is that is called isosceles trapezoid, and that is important for us. Next is your parallelogram. Another type of trapezoid is not much important and it is not asking very frequently, but isosceles trapezoid only will ask most frequently. Next figure here is a rectangle, a square, rhombus, kite. These 4-5 figure you must make mastery to understand, because any 1 or 2 figure also you will not understand, then you will face problem to solve all the geometry questions, because question will be merged. Question will not ask based on the any one property or any of the figure. Question generally it will be merged. Next we can see like in different representation, quadrilateral hierarchy. This is your quadrilateral, trapezoid, parallelogram, kite, rhombus. Different way we can categorize. Now this is little interesting. Like whatever we are making the figure or we are preparing for exam point of view, almost all the times we are thinking about the convex quadrilateral, or you can say this type of quadrilateral. But just suppose if it is a concave, means any of the angle is more than 180, then what will happen? This figure will become concave quadrilateral, and we are generally will not face much for exam point of view. All generally we will face convex quadrilateral, means any of the angle will not cross 180. If it is crossing 180, it will become concave, and most of the times it will not much helpful. And this is called, special name is there, dart. This is another type of trapezoid, multiple type, and this is your crossed quadrilateral. If two quadrilateral are crossing each other, or one quadrilateral is there, you are just twisting. One quadrilateral you have just twist it. It will become like this one, crossed quadrilateral. Just will look little bit more pattern, that looks good. This is, you can say, kite, pattern of kite, like one kite, another kite, how to merge each other. This, based on this pattern you can expect the questions. This is your pattern of dart. Dart they cannot ask, but this pattern they may ask just to check how you are perceiving the geometrical figure, just for your understanding the imagination. They are not going to ask any property related to dart or related to concave quadrilateral, but they may check how you perceive the geometrical figure. And this is your, you can say, series of diamond or series of rhombus. Just will come to the next variant, or this is much important. Once you will we will learn next to next session about the circle, then that time you will face lot of question related to cyclic quadrilateral, or you can say combination of circle and quadrilateral. In place of quadrilateral it may be rectangle or parallelogram, whatever will be there, but combination of circle and quadrilateral. But here we are just going to learn one of the special variant, that is cyclic quadrilateral. If one quadrilateral is inscribed inside the circle, then what are the properties we have to learn? Special properties, like opposite angle will be always equal to 180. Opposite angle, sum of the opposite angle will be always equal to 180. Like here, angle A plus angle C equal to angle B plus angle D must be equal to pi. Sum of total angle will be equal to 2 pi, that is no doubt. Any of the closed four-sided figure, sum of the angle will be always equal to 2 pi. These, but here these and this will always equal to pi. Afterwards, one of the properties, if this is x, this also will become x, means exterior angle of any of the vertex will equal to the opposite angle, opposite interior angle. Exterior angle of any of the vertex will equal to the opposite interior angle. This will only happen if it is a cyclic quadrilateral. In all the quadrilateral it will not happen, but in the case of cyclic quadrilateral it will always happen. Similar way here, if it is y, this also will become y. And this property is going to help a lot for you solving the question related to circle or related to quadrilateral or related to combination of quadrilateral and circle. Then this you understood. Area we can find for cyclic quadrilateral, a square root s minus a into s minus b into s minus c into s minus d. What is s? We can say it is a semi perimeter. Just you have to make the sum a plus b plus c plus d of half, like triangle also we are taking, a plus b plus c divided by 2, that is called semi perimeter. Similar way here, just will divide sum of all the side by 2, that is semi perimeter. Another one, this property is there, it is not very frequently used, but you just keep in mind. Tan of angle of A, B, C, D will be equal to cot A, cot B, cot C, cot D, and that will be equal to 0. And A into C plus B into D, what is this? Product of opposite side, sum of the product of opposite side will be always equal to the product of diagonal, and this is going to become one of the important, because many of the times we will forget to apply this property. Then this property and this property, afterward this property, these all are the peculiar property for cyclic quadrilateral. Just we look through LTI, similar thing has written here. Another extension is there, ratio of diagonal. Based on this property, like AC into BD, I already told AB into CD, product of opposite side, summation of product of another opposite side. Ratio of diagonal AC by BD, how to find? Just similar way we can find AB into AD plus BC into CD divided by AB into BC plus AD into CD. I think easy to understand once you understood this one. Once you understood this one, it will be easy to understand. Next is properties of cyclic quadrilateral. Already we have seen, it is summary, has 4 vertices that lie on the circumference of the circle. That is first criteria. If any of the vertices is not touching the circumference of the circle, then we can't say it is a cyclic quadrilateral. Then first criteria to verify it is cyclic quadrilateral or not, all 4 vertices must lie on the same circle. It is not like 2 vertices on one circle, another 2 vertices on another circle. Then we cannot say it is a cyclic quadrilateral. All 4 vertices must be lie on the same circle, and it must touch the perimeter, or you can say it must touch circumference of the circle. Opposite interior angle add up to 0, means we can say this plus this will be equal to 180 or supplementary to exterior angle is equal to the opposite interior angle, we have seen. Just will come to the opposite of that. In last, quadrilateral as circumscribed about a circle like this one. Circle is circumscribed about a quadrilateral in cyclic quadrilateral, or you can say circle about a quadrilateral anyway, but here just will opposite. Quadrilateral if circumscribing a circle means circle inside the quadrilateral. Last figure we have seen circle outside of the quadrilateral. Now here, if it is outside, then vertices will touch. If it is inside, then all side will become tangent to the circle. That is first criteria. First criteria, AB, BC, CD and DA must be a tangent to the circle, tangent to circle. If it is not tangent, then we cannot say it is a circle inscribed in the quadrilateral. But here few properties will be very interesting, because once you will merge the line from center like this, wherever tangent is there, then it will always 90 degree, 90 degree, 90 degree, 90 degree. What we are getting? We are getting kites, K1, K2, K3 and K4. 4 kites you are getting, and that is correlating so many properties, and based on these properties, further if you are joining, just you join these 2 points, you will get very interesting properties and multiple questions. Again I will discuss this combination, like in circle it is called pair of tangent, means point B we have put the pair of tangent on the circle. In many of the questions last 20 to 25 years in CAT, it is asked based on the kite concept. Multiple kites together. So many symmetry properties are there in kite, like this will be equal, this will be equal, this will be equal, this will be equal, this is 90, this is 90. So many properties are there. Correct? Afterwards, this will be angle bisector, this will be angle bisector. And we have seen in the triangle, in the case of triangle also, during discussion about the incenter and circumcenter. Then this same thing, just we'll try to recap and we'll try to understand if circle is inscribed in the quadrilateral, then what are the properties we will hold good. First thing, we will get 4 kites, okay, and once we are getting kites, then we will able to apply multiple properties. Afterwards, once kite is there, kite another property will be there, this must be equal. Then this one kite, if this is W, this must be W. Here if this is X, this must be X. If this is Y, this must be y. If this is z, this must be z. Okay, means you understood AE equal to AF, B equal to BS, C is equal to this must be. And best properties is this one. This looks very small but application wise very huge. What is property this one? X plus W equal to Y plus Z and X plus Y equal to W plus Z. Okay, means, or this we can extend in little more sophisticated way. X plus W plus Y plus Z, X plus W plus Y plus Z, sum of the two opposite side must be equal to X plus Y plus W plus Z. Okay, this you can remove from here. X plus W means this plus this, sum of the opposite side must be equal to the sum of another opposite side. Okay, or in direct way we can say AB plus CD must be equal to BC plus AD. But it is, if it is divided through kites, then we can take in the fragment. Total sum, it will be 360, that is without doubt. Just we will see few figures. In multiple type of inscription can be happen. Means circle can be inscribed in variety of way. In all the way, this property will always hold good. This will be equal, this will be equal. It will never fail. It will never fail. Any of the case, like here you just look A, D and D. Here if it is C, then this is also C, and if this is B, this is also B. This will never fail. And this figure is little more interesting. If we are putting from center, then what will happen? This will become radius, and afterwards we have seen already this will convert into a kite. Don't confuse, this center will not always the point of intersection of the diameter, it will be different point. This will happen only if it is a square, means circle inscribed in the square, then your point of intersection of diameter and center of the circle both will lie at same point. But any of the other figure, it will be always different point. This is your point of intersection of diameter, this is your center of circle. Center of circle, wherever tangent it will drop, it will be 90, 90, 90 and 90, and this will again form kite like this. This is made one kite, and once you will drop a line from here to here, then you will be able to apply all the properties of kite which is valid. Just we'll look one question, it will give you the confidence. Inscribed in the quadrilateral, given that AB equal to 5, BC equal to 8, this is 5, this is 8, and AD equal to 3, then what is the value of CD? What we have to do? Sum of opposite side must be equal. AB plus CD must be equal to BC plus AD. 5 plus CD, and CD must be equal to 6. Then only this figure will be valid. Just will twist little bit more, not much, little bit. Same type of figure, but information is different. If AE is equal to 2, like this is A is 2, BH equal to 3, this is your BH, this is given 3, CD already given total, this length is equal to 8, and another information is given, BC is 25% more than CD. It looks like also little bigger than CD. How much bigger? 25% more. Find the semi-perimeter of ABCD. What to do? Just will apply the concept of kite. If A is some value is there, just suppose it is 2, then this also must be 2. If this is X, this also must be X. If this is Y, this also must be Y. If this is Z, this must be Z. This simple thing we will apply, and we will get all the four sides, and afterwards we will be able to find the semi-perimeter. Just to look here. This is 2, this is 2, this is just suppose X, this is X. Total CD is given already 8, then this will come 8 minus X, because DG is equal to X, then CG will equal to 8 minus X. Once this is 8 minus X, this will become 8 minus X. Now here it is given already, this is 3, then this must be 3. What we got? total BC is given 25% more than CD, means 1.25 into 8, this total is 10. If total is 10, just to equate with BH and CH, means 3 plus 8 minus x must be equal to 10. If it is equal to 10, means x will be equal to 1. Problem is solved. You got all the side. If x equal to 1, then AB already given 5, CD already given 8, AD will become 2 plus x, that is 3, and BC already you know it is 10. Semi-perimeter, just to add 5 plus 8 plus 3 plus 10 equal to 13, or sum of any of the two opposite side. Just to take 5 plus 8, this will be 13, that will be your semi-perimeter. We'll come to the next figure. We understood about the general properties of quadrilateral. Just will make little extension of the quadrilateral. It is, next figure is your trapezium. Trapezium is, mainly we will focus on isosceles trapezium, like when AB and CD is parallel to each other and AD and BC is not parallel to each other but equal to each other. Next condition, angle A must be equal to angle B and angle D must be equal to angle C. All these four conditions will valid, then only we can say it is isosceles trapezium. But it is very symmetrical figure. Angle A equal to angle B, angle C equal to angle D. AB must be parallel to CD, but AD should not be parallel to BC, but AD must be equal to BC. No need to confuse. AB is parallel to CD. Very good. AD must not be parallel to BC. Very good. But AD must be equal to BC. If it is not equal, then it will not make isosceles trapezium. It will make trapezium, it will make trapezoid, but it will not make isosceles triangle. To make isosceles triangle, these two conditions must be, these angle condition and these angle condition. These two are making isosceles. Correct? These are common properties. AB is parallel to CD and afterwards AD is not parallel to BC. This is for any of the trapezoid. We can make like this also. Only conditions would be this is also trapezoid. This only parallel to each other. But these two are not equal to this different type of trapezoid. But here, if AD is equal to BC, then all angle property also will become valid. By default, once both are equal, automatically angle A will equal to angle B. Angle C will equal to angle D. If it is not equal, then angle also will not valid. Means these two properties are special for isosceles trapezium. Sum of total angle 360, no need to repeat. PQ, if P is the midpoint and Q is the midpoint, if you are joining the midpoint, then it will equal to the half of AB plus CD. Means you can say this is called median sometimes. One time in CAT it is used, median of the trapezium, 1 or 2 times. We should not confuse what is the median. This is median, just this value of the PQ. P and Q are midpoints of the side AD and DC. Area we can find any of the way, just to make the sum of two parallel side. Just otherwise you can break in this two triangle and one rectangle. That way also we will be able to find it. That is only summation of this triangle, this rectangle and this triangle. Okay, but here directly we can write half of the AB plus CD, sum of the parallel side multiplied by any of the height AE or BF, because one thing is sure, AE will be equal to BF. There is no doubt, because everything is symmetric. Everything is symmetric. Anyway, AB and CD is parallel to each other, means distance between two parallel lines will be always same. If any railway track is going anywhere, you will find distance will be always same. Similar way here, AE must be equal to BF. Just will come little bit more properties related to trapezium. This is going to help a lot, because whatever we have seen, that is, you can say, common properties. This is little more useful for your exam point of view. Just suppose length of the side of trapezium has given A, B, C and D, and diameter has given diagonal as given E and F. Means all the value, if we know A, B, C, D, E and F, then how these values will be interrelated to each other. Just to make sum of all the squares of side a square plus b square plus c square plus d square, it must be equal to the sum of the square of diagonal plus what is the difference of these two parallel sides c minus a, that is square. This is very good properties and many of the times we will able to use for, you can say, high level of questions. Just suppose another property is if AP and PD are given in the ratio m ratio n, and similar way here BQ and QC also m ratio n, then value of PQ or length of PQ we can find m by m plus n into CD plus n by m plus, this is just a simple division, we know already. In lines we have shown the internal division or external division, this is internal division, then this way we can find. The same thing we can write in different format, m into CD plus n into AB divided by AD, because at the denominator it will come m plus n, and m plus n we can say it is equal to AD or BC, whatever you like you put it, either AD or BC. AD equal to BC, if AD equal to BC means in the case of isosceles trapezium, then both of the diagonal will equal, E must be equal to F in the case of AD equal to BC. Other case it is not certain, this diagonal will be equal. Now another property is that is holding good, like here AO ratio OC, like this one, this ratio this diagonal will always divide to each other in the ratio of the side of the ratio of the parallel side, always it will be A ratio C. BO ratio OD, it is also A ratio C. It is ratio, not exact value. Don't feel like A equal to 2 and C equal to 4, then this will be 2 and 4. No, but in the ratio of 2 ratio 4. It may be 4 by 8, it may be 6 by 12, whatever, but in the ratio of 2 ratio 4. This is also good property. I think we have just made the surgery of trapezium. Beyond that, no need to go. Another few properties. This will give you the high level of confidence. Trapezium inscribed in a circle will always isosceles. If any of the trapezium you are inscribing in the circle, then you can't inscribe any different type of trapezium. Always it will be isosceles only. You don't have the way. If you want to inscribe in the circle. Midpoint, if you are joining any of the trapezium, it will give the 4 similar triangle. This. And we can correlate so many properties, whatever similar properties, similar triangle can be. Just we'll look through some LTI. Many of the types of trapezoid, like based on the side, scalene trapezoid, no sides are equal, all 4 are different. We can say it is a quadrilateral. We can't say it is a trapezoid, but only thing will be there, like these two sides will be parallel, but lengthwise all will be unequal. And these two sides will be again non-parallel, non-equal. Afterwards, isosceles trapezoid, when these two are equal, these two are parallel. This we know already, these two parallel, these two equal, and these two are non-parallel. This is most famous category among trapezoid or among trapezium. Based on the angle, acute trapezoid, if two adjacent angles are less than 90, this one and this one. Obtuse trapezoid, two opposite angles are obtuse, this and this. Right trapezoid, two adjacent right angles, these sometimes will be useful for problem solving point of view. Because just suppose if this trapezoid, any circle inscribed, or this trapezoid, any circle circumscribed or inscribed, then based on this 90 degree, so many properties of right angle triangle can be correlated. Due to this, sometimes for problem point of view it is helpful. Next, similar type it is isosceles trapezium. The trapezium which has legs of equal length is called isosceles trapezium, like AD equal to BC. I think no need to explain, we understood. Same thing it is explained, or it is given in, this is long base, this is short base, that is called altitude. Different way you can give your name, there is your choice. This is leg, this is leg, this is base, this is base. Parallel side is called base, and another two side which is non-parallel, this is called leg. This is called median or mid segment. So many names. Here it is called median. We know it is formula of median, just average of A plus B. A plus B, sum of the parallel side. Here A is a long base, B is a short base. This so many name will be there. But overall, you understood. Now you are in imagination how to imagine or how to see the trapezoid or especially isosceles trapezoid, and you will be able to correlate all the properties. Just will come to the next and most important among quadrilateral, that is parallelogram. Give little extra concentration for next 10 to 15 minutes, that much only. A quadrilateral of opposite sides are parallel to each other. Here what are the conditions? Trapezium we have look, only one set of sides are parallel to each other, another one set was not parallel. But here both set or both pair will be parallel to each other. Like AB will be equal to CD and AB must be parallel to CD. Next, AD must be equal to BC and AD must be parallel to BC. Due to that, what will happen? This angle A must be equal to angle C. AB and BC will not equal. This is different. AB and BC will not equal. If this will become equal, then it will be a case of a square or related to a square, means rhombus or something. But here AB will be different value, this will be different value, but parallel to each other. This angle must be equal to each other. Angle A must be equal to angle C, angle B must be equal to angle D. Once you visualize the figure properly, you will able to understand what can be equal, what cannot be equal, what can be bisect, what cannot be bisect. Only thing is there, you should able to imagine or you should able to see the clear picture. Clear diagram if you are able to make in your mind, you will able to visualize which can be equal, which cannot be equal. Just to move the points from one point to another point, like just here, one diameter you move here, there, you will able to understand these will always equal, means this will be bisected by each other. Diagonal will be bisected to each other, but not perpendicular bisector. This will never equal to 90 degree in the case of parallelogram. Now, sum of angle A plus B, it must be equal to 180, or angle A plus D must be equal to total angle 360. OA equal to OC, OA equal to OC and OB equal to OD, but AC will not equal to BD. Respective diagonal will be bisected by other diagonal, but both of the diagonal will be different. If it is becoming same, then it will become a square. Correct, it will become a square. Triangle ACD, ACD means any of the diagonal will divide the parallelogram into congruent triangle. This is going to help a lot to correlate the properties. Again, another diagonal means BD will divide in two congruent triangles. Afterwards, we will able to correlate the area of the ABCD. It must be equal to CD into AE, or we know it is a base into height, simple thing. If it is given like a rectangle, then we know it is a L into B. Similar way, here height we found AE and base we have CD, then CD into AE, or we can represent in terms of angle also, like sin theta. If this angle is given, included angle, like two side AD and CD, or any of the angle like BC or CD, any of the angle you can take. Anyway, it is supplement to each other. Either you are taking this or this, it is not going to change. Sin theta equal to sin pi minus theta. Then AD into CD sin theta, that is also a formula for area. And triangle ACD, just suppose this triangle, what will happen? This will become base, this will be base it is, and AE will be height. Then we can write half into CD into D, or means half into area of the ABCD. Based on that, we are telling they are dividing into congruent triangle. Perimeter we know it will be 2 into AB plus BC, and one of the properties that will hold good for parallelogram, AC square plus BD square means sum of the squares of the diagonal must be equal to the AB square plus BC square plus CD square plus AD square. This is one of the good property. Sum of the squares of the diagonal must be equal to the sum of the squares of all four sides. Just we'll look little bit more. Just suppose in parallelogram, anywhere one point is there. It is not necessary it is a point of intersection of diagonal, but if it is valid for any of the points, then it must be valid for point of intersection of diagonal also, because that will fall down in this same set, correct? This is just any point anywhere. What you have to do, from this point you just merge 4 vertices, just to merge 4 vertices. Then what are the property will valid? A1 plus A3 means sum of the opposites equal to A2 plus A4, and this will be equal to the half of area of the ABCD. This will always valid. This will always valid for rectangle also and square also. Here theta will never 90 degree, means it will bisect to each other, but it will never bisect perpendicularly. X will never equal to y, means it will never bisect the angle. Angle will not bisected. This vertex angle will not bisected. X will not equal to y. Another few properties, just in terms of variety of figures. If you want to insert a parallelogram in the circle, or just another way we can say, if you want to circumscribe a circle about a parallelogram, then you will not able to make a parallelogram, always it will convert into rectangle. You don't have option. If you want to insert one parallelogram inside the circle, it will convert into a rectangle, and BD equal to AC means it will become diameter. And if you want to circumscribe one circle by parallelogram, then you will not able to do. Why? It will convert into rhombus. It will convert into rhombus. And point, if you are meeting the point of midpoint of all the sides, means H, E, F, G, then this will be another parallelogram. Means just you are merging the midpoint of a parallelogram, then it will create another parallelogram. Just visual, no need to write in language, because geometry maximum thing visual. As much as you will able to understand based on the diagram, it will be much helpful. Just suppose two parallel line you have, L1 and L2. Between L1 and L2, any type of parallelogram you will make, it will be a squeezed or whatever, area will be always same. Condition is AB must be equal to CD. If this you are changing, then area will change. But same base, if you are making different shape of the parallelogram, but area will not change. Why? Because base is not changing, height is not changing. We know the distance between two parallel lines is fixed, either here or here. Then any of the parallelogram you will make, it will be always area will be same. Just will recap whatever we have learned about the parallelogram based on the LTI. Opposite sides are parallel, congruent, congruent. This will be supplementary, diagonals are bisect each other. We understood all. No need to repeat again and again. This will be E plus F equal to 180. This plus this will be 180. This plus this will be 180. And based on that, we will able to make all the correlation. Here, congruent side, like just by seeing itself, we will able to say this is equal to this. This is equal to this. Afterward, this is equal to this. This is equal to this. Over. That much we know. It is enough. Perimeter we know. Area we know. And afterwards, these all are angle properties. Angle A plus B equal to 180, B plus C 180. Any of the two consecutive supplementary angles, it will be always equal to 180. Either you are taking B plus C, C plus D, D plus A plus B, always it will be 180. But opposite angle will be equal. Opposite angle will be equal to angle A equal to C, B equal to D. But any two consecutive angles, it will be always supplementary to each other. This one figure itself is sufficient to explain everything. These two are equal. These two are equal. These are equal. These are equal. Opposite angles are equal. Over. Just will come to the next figure or next geometrical figure based on the quadrilateral, that is your rectangle. This is very symmetrical figure. Parallelogram was little squeezed, means two side, one pair of side was not parallel to each other. But rectangle, it is all the sides, you can say opposite side will be parallel to each other. One pair parallel, another pair also parallel. AB must be equal to CD and must be parallel to each other. BC must be equal to AD and parallel to each other. Now, just by common sense we will be able to understand what diagonal will happen. Diagonal must be bisected also and all will equal, because this angle is 90 due to, in parallelogram this was not 90, this was not fixed, it can go any value, but here this angle will equal to 90 due to a parallelogram of perpendicular side is called rectangle. This is perpendicular side. Okay. Means all these will become equal. In parallelogram only opposite was equal, but here all four will become equal, and that AC and BD or any of the diameter we will be able to find in simple way, length into width, L square plus B square. Simple formula we know. We can apply the Pythagoras principle. L square plus B square equal to AC square, and BD square also same. This is B, this is L. Okay, this is all right angle triangle. Once right angle triangle, it looks easy also, but it is creating more hurdles also. Then multiple properties will hold together at a same time, and we have to handle all properties very properly, otherwise chances of mistake will be there. X will not equal to Y means it will not going to become an angle bisector. Diagonal will not angle bisector, but X plus Y will be 90. It is fixed. Angle A equal to B equal to C equal to D always 90. Area, length into width. Triangle AOB equal to triangle BOC, COD, COD, it will be 1/4 of ABCD. Means all will equal to. Perimeter 2 into L into B. All properties of parallelogram will valid for rectangle, and all rectangles are parallelogram, but vice versa not true. All rectangles are parallelogram, but all parallelograms are not rectangle. Then whatever properties of parallelogram we have discussed, it is equally valid for rectangle also. Just we'll look little bit more. Like here, if you are joining the midpoint of the rectangle, then what will happen? It will give you PQRS, that is rhombus. If you are joining the midpoints of the rectangle, it will give you the rhombus. If PQRS is the midpoint. Why it is rhombus? Because all will become equal. This is the region. But this angle is not 90. If it will become 90, then it will become a square. A square and rhombus we know only difference is there, angle will not 90, side will be equal. For a given or fixed perimeter of rectangle, this is one of the properties that is related to algebraic expression. We know it is how to minimize, how to maximize, correct? If anything is given, perimeter is given or sum is given, then a square will have the maximum area. Why? If sum has given A plus B plus C equal to constant, then A into B into C will be maximum when A equal to B equal to C. Then a square is having only area formula A square means A into A, due to it will be maximum when perimeter is fixed. Just will look little bit more. I think just visual it is sufficient. Just I will mark, will not speak. Enough. We understood all the properties together. Same thing it is written. Opposite sides are congruent, opposite angles are congruent. Consecutive angles are supplementary to each other. What is consecutive angles? This plus this, 90 plus 90. It is valid for parallelogram also. Diagonals bisect each other. All are equal. I think we understood. Just we'll solve few questions to get the grip of the concept whatever we have learned. And question can be created anything. Just it is a like, because it is geometry, it can be imagined any complicated figure, because they have to trap you. That is purpose. They are conducting the exam. Their purpose is how to trap you, how to make you confused. That is their purpose. But our purpose is we will not get confused. Whatever you will try to trap, we will have the some idea how to come out. Similar way, just will look, this is one of the question. This looks like one of the quadrilateral ABCD. but some information more is given. ABC is a equilateral triangle, means this is equilateral triangle. One thing we can say, if it is equilateral, this all three will be equal. Find area of ABCD. ABCD we have to find the area. Something which is given, AC equal to 25. If it is 25, then this also 25, this also 25, because it is equilateral triangle. AD is greater than CD. Okay, let it be. But AD is less than AC. I don't know what is the purpose to write the or given this information. But anyway, it is your previous year CAT question, then I can't change whatever information given. AD is 20% less than AB. AD is 20% less than AB. Okay, then we have to find the area of ABCD. One thing is very clearly, it looks this quadrilateral is divided in two areas, A1 and A2. A1 already side also given 25, then finding this is much easy. Only thing we have to find this area A2. A2 also we can find half into CD into AD, half into base into height, but only exact value is not given. How to find? Just we'll look based on the given information itself. This is 25, 25, 25 given. This will become 60, 60, 60 because equilateral triangle. This is already 90. Then this x plus y must be equal to how much? 90 together, not individually. Because ACD is right angle triangle, x plus y must be equal to 90 because one of the angle itself 90. Total sum must be 180. Then x plus y will equal to 90. Now, CD square in this triangle, if we are looking ACD, then CD square equal to 25 square minus 20 square equal to 15 square, means CD also we got 15. How we got? This is given already. 20% less of 25, it will become 20, means AD is 20, this is 15, and condition is given, AD must be greater than CD and AD must be less than AB or AC or BC, because it is equilateral triangle. Both all conditions are valid, we are not violating any condition. Now this is our area A1, this is A2. Then A1 it is ABC and A2 ACD. This is equilateral triangle, root 3 by 4 into 25 square, simple. This is also simple, half into 15 into 20, little bit calculation. If you are good in Vedic math, it will not worry you. It will not worry you. Like if you have done all the session of Vedic math properly and day to day you are doing the practice, these all calculation will not worry you. You may take hardly 3 to 4 seconds. It will become 265.6 plus 150 approximately 416. Which choice? B for Bombay. B for Bombay. Good question. Now we'll come to the next question. Next question also something has given, and one thing always we have to remember in geometry, whatever figure is given, we always search where we can put one more line to make this figure more symmetric, or to convert this figure in any of the regular figure. But don't put line here, there, anyway. Always we have to find line parallel to any of the given line or perpendicular to given any line. These two only mainly we have to look. How to join two points to make figure little more regular, little more symmetric. Similar way here, just I will tell you, angle A is given 110 degree, BC equal to CD. Where is BC? BC is equal to CD equal to AE. This indication is telling we have to do something. Then find CDE. CDE, this angle you have to find. Just by looking itself, just suppose if we are just joining these 2 points, what is happening here? AE must be equal to BD, then BCD will become equilateral triangle. Once you understood this, question will become easy. If it is equilateral triangle, this will become 60, and this only we have to find based on the parallelogram properties. If this is 110, this will be also 110, 110 plus 60, 170. I think none of these. Just will solve properly. Like this, just we have dropped one line, or we merged point B and C. This become equilateral triangle, 60, 60, 60. This is 110, this also 110. This total angle will become sum of 110 plus 60. It will become 170. Option D. Option D. Many of the where anywhere if it is given none of these, we extra careful. We extra careful. Otherwise, chances are there you make mistake. Just will come to the next question. Interesting question and previous year CAT paper question. Looks like easy, and due to I told right angle trapezoid sometimes can be converted into a good question because we have two right angle. This will have so many properties we will have to correlate. Just will read the question. dm equal to 1, this value is given, and gn equal to, where is gn? Gn equal to 4. Find the radius of circle. One thing is very sure, from here any point wherever tangent is crossing, if you will put drop, it will always 90 degree. This is one of the properties. Due to this right angle, angle E and F, it is giving one extra edge. This figure ME, or if you are putting some name here, just to put any of the name, just suppose it is A, then MEAC will become a square. This is radius, this is radius, this is square, means all side will be equal. Now just suppose if we are dropping one line from here to here, why it is purpose? To make it further easy to convert one more symmetric figure, this is right angle triangle. Now it is totally bisected or totally divided in proper way. Just will look in this way. Now it looks very good and we will be able to solve very easily. This is x, this is x, just suppose this is radius, this is divided like this also will come x. Okay. Now CD, this value CD, this one CD. CD will become 2x because it is equal to Mn, it is equal to EF, both value is 2x. CG, where is CG? This is your CG. CG will equal to Gn minus Cn. Gn is given already 4 and Cn we can make equal to dm because this is 90, this is 90, all are 90 due to what will happen? Cn must be equal to dm. Okay. Then Gn minus dm, 4 minus 1, it will equal to 3. Means this you got 3. Means this triangle, this value is 3, this you already know 5, then automatically you can say it will be 4. Just it is a Pythagoras triplet. Means 4 is equal to 2x, then x will equal to 2, and that is your value of radius. Good question. Good question. You can expect this level of question in your exam. Now we'll come to the next question. It is just a division, but initially you may get confused. And in once you have not put your just 10-20 seconds, you may do mistake very easily. A rectangle is divided into 5 congruent rectangles. This is also from your previous year CAT paper. 5 congruent rectangles. A perimeter of rectangle is 88 centimeter. This bigger one. Find the perimeter of a small rectangle. This is divided in 5 rectangles. 1, 2, 3, 4, 5. All are congruent to each other. I mean, just suppose if this is L, this is B, then this will be B, this will be B, this will be B, this will be L, this will be L, and this will be L, this will be L, this will be B, this will be B, this will be L. All are congruent to each other. Then what will be the perimeter of any one of the rectangle? What will do? Very simple. It is not complicated. Only thing you have to do, L plus L, 2L must be equal to 3B because it is a rectangle. This side 3B must be equal to 2L. Once you have solved, afterwards you just correlate this perimeter equal to 88, we will get the answer. Just will look like this way, a proper way if you want to solve. Otherwise, if you are understanding the session or previous session or many of the techniques, just by seeing itself you will able to mark it. Just seeing itself you will able to mark it what will be answer, but just try to solve proper mathematical way. L and B, L, 2L equal to 3B. 2 into 2L plus B is given 88. 2 into 2L plus L plus B, or we can say L plus B, this is this plus this multiplied by 2, it will be perimeter, that is given 88. Then here just 3L plus B equal to 44. Value of B we can put 2L by 3. It will be like this. L you got 12. L you got 12, then V will equal to 8. Then perimeter of any of the rectangle will be L by B, it will be equal to 2 into 12 plus 8, it will be 40. It will be 40. How we can mark the answer? Very easily. How we can mark? Only thing is there, 20 cannot be, 48 cannot be. Only confusion you got 32 and 40. Only confusion you got 32 and 40. I will tell you later how to pick between any two. So many sessions will be there. In geometry still 7-8 session is there after that also, and that is blockwise level. Again you will come to the pattern and question bank, and afterwards revision session. Plenty of sessions are there and plenty of questions we will discuss. Little bit more information is needed to apply or to eliminate all the choices. Just will come to the question number 7. If L into B equal to 2 into L plus B, what is given? Value just to look, don't look unit, because unit if we will look, then this statement itself falls. Why? Because this is area, this is unit will be always meter square, this is perimeter, this unit will be meter. Don't look unit, just to look logical analysis, value of area is equal to the value of perimeter. Then how many rectangles with integral sides are possible? CAT paper, it looks like a geometry question, but basically it is a number question. Basically it is a number question. Just you have to fit the number, integral value of the numbers which are satisfying this equation. That much only we have to do. It is not worried about rectangle or anything. This is given one of the equation a into b equal to 2 into a plus b. Then how many integral value of a and b is possible? Question is this. And many of the questions we have solved in numbers and algebra based on that. If you know little bit, you will be able to mark it too. Because sum and product, if it is equal and it is multiplied one side 2 by any of the numbers, then most of the chances it will be 2 possibilities. Just will look. 2 L plus B equal to L into B, just to solve if you want to do. Case 1, L equal to 4, then B equal to 4. If L equal to 3, B equal to 6. Beyond that, we don't have a scope. This will become a square, but a square is also a rectangle. If just we look set and subset type, then this is your quadrilateral. It is not perfectly round. This is your quadrilateral. Inside it will come trapezium, parallelogram, rectangle and a square. Set, subset, subset. All squares are rectangle also, but all rectangles are not a square. All rectangles are parallelogram, but all parallelograms are not rectangle. Similar way, this we can treat as a number of rectangles, means total two rectangles we will be able to find which are having integral value of sides. Just will come one more question. Just I am leaving you another 5 minutes. Just will relieve you. But this session is going to become one of the milestone session to understand your quant, or you can say especially for geometry. If angle CAD is given 35 degree and angle CBA is given 75 degree, find ACD. Okay. One thing is sure, they are asking ACD and something, then we have to merge this. Without that we will not able to visualize. CAD now we are able to visualize this is, and ACD we have to find this one. Okay. Another angle is given, it is 75. I think so. CBA, yeah, CBA 75. This we know, this is 75, then opposite side. This is cyclic quadrilateral. Some of the opposite angles in cyclic quadrilateral will be always supplementary to each other. If this is 75, this will be 105 over. Just to have, if you want in proper way, just to look this one. This is 75, it will be 105. This is given 35. Finding this is any difficulty. This is triangle 105, 35, 140 is over 40 degree. This will become angle DCA or ACD. Option C, C4 Calcutta. I think we have done. Another one more session is there related to quadrilateral and its properties. In that session, next session, we are going to discuss about the square, rhombus, kite and other miscellaneous type of quadrilateral. Then just we'll recap the session and we'll close it. Recap of the session, what are things we have discussed in last 40-45 minutes, just I will recap it. Then before closing the session you will be able to recall or you will be able to refresh whatever I have discussed. About quadrilateral I discussed some common properties, and afterwards I come to one of the variant of the quadrilateral, that is cyclic quadrilateral, and together we have discussed if just opposite, means if circle is circumscribing the quadrilateral, another was quadrilateral is circumscribing the circle, and both of the case are having peculiar properties, and that peculiar properties are very much frequently used for question setting. Properties of quadrilateral we have seen, general properties and special properties, trapezium and its properties, and afterwards we have seen circle inscribed quadrilateral, that was important because it can be used in multiple way, and circle chapter also it is going to help because it will create 4 different kites, and all kite properties and right angle triangle all will be able to apply together. Next we have seen about the parallelogram and its properties, that is most important, due to I am putting again here 3 star. If 2 parallel side is there, another 2 side is not parallel, then it is parallelogram. Opposite vertices angle will be always equal. Rectangles and its properties, if all are perpendicular means all the corner angles or vertices angles are 90 degree, then it is rectangle. This is one of the most symmetric figure, and we have seen the lot of questions, various tricks and techniques. I think we have done this session. One more session is there related to quadrilateral and its properties. There we will look and we will just do the surgery about the square, then rhombus, then kite and other figures related to quadrilateral, and afterward we will solve lot of questions related to all type of quadrilateral together, because once you understood all figures related to quadrilateral, we will solve the more beautiful and complicated question. Then till that, thank you very much.